Hello and welcome to Physics Teacher. In today's video, I'm going to be going over a lab that I do with my grade 12 chemistry students, where we are going to experimentally determine the molar heat of fusion for water. Now, if you want to follow along with the observations and calculations, you can download our handout for free in the description. Now, first thing we're going to do is to figure out the mass of one of our ice cubes. So we're going to zero our scale here. And first, we have our styrofoam cup that we'll be using. So let's figure out what the mass of the cup is. So we've got 2.577 grams. And then let's take one ice cube, put it in the cup, and we'll re-zero. Weigh them both together, and we have 22.207 grams. So you can subtract those two measurements to figure out the weight, or the mass, of the ice cube. Next, I have boiled water here, and I'm going to put about 90 milliliters of into our graduated cylinder, but we're going to determine the mass of the water using the scale, not the density. The scale's a lot more accurate than this graduated cylinder. So let's figure out the mass of the graduated cylinder. It's 46.380 grams, and then I'll put in about 90 milliliters. It's a little bit less, but that's okay. Together, their mass is 130.56, reading it backwards, 592 grams. So you can subtract those two to figure out the mass of the water. Next, what we're going to do is determine the initial temperature of the water. So we're going to put our temperature probe into the water. Looks like it's getting close to the actual value now. We're at about 82.7 degrees. Now we will mix them and figure out the final temperature once the ice has fully melted. Looks like the ice is almost fully melted there, and our temperature scale is starting to level off. Okay, I think that's good. We can see that it has leveled off a fair amount. The rest that we lose will be to the environment. So our final temperature is at 47.1 degrees Celsius. All right, now that all of our measurements are done, let me show you how to do the calculations. So here are the results from our experiment, and now we're going to try to calculate what that molar heat of fusion is for water. So first, the masses. Now, we never actually got the mass of the ice, but we got the cup and the ice and the mass of the cup. So if we subtract these two values, then we will figure out what the actual mass of that ice is. So well, take the larger number and subtract the smaller number. Right, so we get 22.207 and we get 19.63 grams. Now we're going to do the same for the hot water. We're going to subtract these two values. Again, take the mass of the cylinder and the water and then subtract the mass of the cylinder. Okay, and then we'll end up with just the mass of that water. And we get 84.212 grams. All right, so the ice, what's happening to the ice is first it melts and then it's going to heat up to this final temperature for the mixture. So let's look at that. Since it's gaining energy, we're going to calculate that Q gain. Now there's two things happening again. First it's melting, so that's the number of moles, times by that molar heat of fusion, and that's what we want to find. And then we also have that temperature change. Once it's melted, it heats up to 47.1, so that is MC delta T. So let's first calculate what this MC delta T actually is. Let's do that on the side here. So we have the mass, which is 19.63 grams, times C, and it's already melted, so that's for liquid water, so that's 4.18 joules per gram degree Celsius, all times by that temperature change, so final minus initial, so we get 47.1 degrees Celsius, and then minus 0. So when we do that, we get an energy of 3,865 joules. Or if we divide by 1,000, that's 3.865 kilojoules. All right, let's look at the hot water. So the hot water is losing energy. So this is going to be Q lost. And though it doesn't change state, so we can calculate that loss of energy with simply MC delta T. So the mass was 84.212 grams. C is the same for liquid water, 4.18 joules per gram degrees Celsius. And then our change in temperature is final, so we have 47.1 minus initial. Initial is a larger temperature, so this is where our negative is going to be coming from, 82.7. And that's going to give us negative 12,531 joules, or divide by 1,000, we have minus 12.531 kilojoules. All right, so now we're going to use our equation for the principle of heat exchange, where Q gained is going to equal the negative of Q lost. So Q gained, we have this N delta H. Then we have plus our 3.865 kilojoules. And that's going to equal negative this negative amount. So that's a double negative. We're just going to get 12.531 kilojoules. And then we can take this term and move it to the other side and subtract it, which will leave us N delta H is equal to, if we subtract these two numbers, we get 8.6 kilojoules. All right, so we're almost there. We almost solved for our molar heat of fusion. We just need to divide by the number of moles. So let's just go to the side here and calculate how many moles we have. And this is for ice, because we were looking at Q gained. So the number of moles is equal to mass over molar mass. And the mass is 19.63. And the molar mass of H2O is 18.02 grams per mole. So we get about 1.089 moles. All right, so let's go back over here. We can figure out what our molar heat of fusion is by dividing by that number of moles, N. So we get 8.666 kilojoules divided by 1.089 moles. And we get our experimental molar heat of fusion to be 7.96 kilojoules per mole. Now the actual value for the molar heat of fusion for water is 6.03 kilojoules per mole. So we can compare these and find a percent difference. Alright, so our percent error is going to be equal to the absolute value of the actual value, so 6.03 kilojoules per mole, subtract by our experimental value 7.96, and then divide it by that actual value 6.03. So that's a dimensionless ratio, and then multiply by 100 to get a percentage. And when we do that for our lab here, our percent error is 32%. Not bad for all of the heat loss to the environment. Well, that's it for the lab. I hope you enjoyed it. If you liked it, please leave a like and subscribe so you don't miss more.